Hello everyone, welcome back to alkaline hydroxide 784, and today in the mathematics series we will be doing normal distribution. Earlier we saw binomial distribution, so now let's see something that's a bit more normal, right? Okay, I think the reason why it's called normal distribution is because it makes more sense. Like in real life we have this thing called the bell curve. That's pretty much what it is. Yeah, it's applicable to normal situations. Yeah, okay, cool. That was definitely not funny. Okay. So how does normal distribution work? Well, of course you have to imagine that bell curve picture in your head, and the middle of the bell curve is like the mean of the normal, the average value. And as it goes towards the sides, it tapers off. There's lesser instances of that particular value. So that's how it kind of works. So when you apply it to real life situations, you're kind of trying to fit the the measurements in real life into a normal distribution, as in into a bell curve of some sort. So yeah, you can then use the normal distribution probability model, and you would be writing it as capital N bracket mu and the thing that they use to represent variance. Yeah, that thing. So so standard normal distribution. Okay, why is that one of the points? Like what do they expect us to remember when we see that word? Anyway, never mind. That's not, I'll just go in whatever I remember. So um right. So the first thing you should know is what are the different things you might need to take note of in a normal distribution. So you have your bell curve and you have the middle point, which is your mean. It's the highest point of the bell curve. And you also need to know the standard deviation or the variance, because standard deviation is the square root of variance. So yeah. So when you know one, you know the other. So how do you get variance? Once again, it's actually the variance is like the average of the differences between the number and the mean, in the sense. So so if you get each of the number, if you subtract the mean from it, you get a difference. That's like the variance from the mean, like the deviation from the mean, right? So when you square this particular number and you add them all up and then you average it, you get the average deviation from the mean. So in a way, this is the variance. And when you square root it, you get standard deviation, in the sense. So yeah, that's how you get variance. But you don't really need to use this formula, because in the question they'll give you something with the ex and the ex squared or something like that. So what you can do is you can use the expected um e of x squared, so the expected value for x squared and the expected value for x. So what does that mean? The expected value for x squared would be, like, for example, if you had the all of the numbers in your data set and you squared everything and then you average that out. So it's not the square of the mean, it's the mean of the squares, in a sense. And then expected x is your mean as usual. So yeah, if you minus one from the other, you get the variance, I believe. Yeah, I think so. Or is it the standard deviation? Whatever. So yeah, that's pretty much it. So what do you need to do now is you need to actually go on to the next point. Okay, anyways, So as you know, the bell curve is quite symmetrical, right? So like one side is like the mirror of the other, and that means that if you find the value for something on one side, it would work for the other side as well. So now let's go to find doing actual things. So the first one would be to find the value of the probability of that x is smaller than the mean or something like that, for example. So not necessarily smaller than mean, but smaller than some particular number on the distribution. So in the bell curve, you know that the mean is right at the center, and to the left of the mean, there's all of numbers that are lesser than it, and to the right, there's all the numbers that are greater than it. So for example, if you wanted to find the probability that x is smaller than 4, for example, and your mean is 5, and if you have your bell curve already defined from your n that particular model, you can then use your GC. You can either find the area under the graph from negative infinity to 4, or you can use your GC and then go to, like, I don't know, the stats, the button that says stat on it, and then you can go to the normal deviation option and then use that to find your probability of this lesser than that. You just need to type in all of the values, like the mean and the variance or standard deviation, actually, because they will ask you for standard deviation, so you square root the variance and you get standard deviation. So after you do that, you can then just press enter and it will do all the work for you. You don't need to think. Yay. So this isn't really like binomial distribution. You can't just go around calculating it unless you know how to use that table in your data booklet. But even then, it won't be super accurate. So I don't know. So you can use this for any particular probability related to the normal distribution curve. If it is more than, obviously you have to look at the area to the right. If it's less than, you look at the area to the left. Just take note of it in that sense. So you just need to know all the values of the mean, standard variance, all those things, and you can easily calculate it with your GC. And that's why it's very important to have your GC charged during your paper 2, because you will need it for sure, unless you're very good at doing this manually using a table. So right, what else do we need to do in normal distribution? So if you do get the value of the probability instead, there's another option in your GC to help you find it backwards. I kind of forgot what it's called, so, and my GC isn't on, so maybe if it's on when I'm recording the video part, I'll show it to you. So you can use that to find out the value of one of the, either the mean or the variance, based on which one is unknown. So you just need to use that and then put in the probability or and whatever other values that you have, and then you can find the unknown value. Okay, so the next one is about calculating the expected value of stuff like ax plus b or ax plus by, and also the variance. So when it comes to calculating expected value, it's pretty simple because it's kind of like adding it up normally. So it's, for example, if you're trying to find the expected value of ax plus b, it's just, okay, so let's say ex, so you want to make it expected value of ax. So you just need to times it by a. It's pretty simple. So if you want to find the expected value of ax plus b, you just times it by a and then plus b to it. Yeah, it's very straightforward. Just follow what's written in the expected bracket. But when it comes to variance, you would need to do something else, because variance is about the deviation from the mean. So if you have your x and you're just saying variance of x plus b, you don't need to change it at all. It's the same variance, because if you think about it, when you add b to all of the values, the difference doesn't change. But when you times the mean, like the x by a, like a, if you find the variance of ax, then you would have to times it by a squared, because the like the inclusion of a as a multiplier also increases the distance in terms of the value, so the variance is affected by this particular a. Therefore you have to make it a square and not just a. So when it comes to ax plus by, if you're doing expected, okay, please note that a and y have to be independent in this case because otherwise it will be very confusing. So if you have expected of ax plus by, you just add it up as normal. If you have variance of ax plus by, you have to do the same thing again, which is the a square and the b square. A square x plus b square y. So once you do that, you can find your expected values and variances pretty quickly. Hopefully I didn't confuse you more. And I hope that I said everything correctly because I don't remember stats. Oops. Okay, yeah. So yeah, I'll just show it to you later I'll show it to you in the video if I have my calculator on how to calculate all of these values. So yeah, I guess that's pretty much it. There shouldn't be anything else left for me to say. Or maybe I didn't say enough stuff, I'm not sure. So yeah, I think the final thing to mention is that normal deviation is it's like a very idealistic thing as well. I mean, binomial is idealistic in a way, but normal deviation is still pretty idealistic, even though it is a bit more realistic in terms of the real world stuff. Because if you think about it, the data that you get isn't necessarily gonna follow the bell curve very smoothly. So it's more of like an approximation of the realistic scenario rather than a fully realistic thing. That's why you have your standard normal distribution, which is what you get as a simple little bell curve thing, which doesn't have any bumps or anything else involved in it. And that's why in the topic after this sampling, you get to see the difference between the actual population and what you would see in a normal deviation, a standard one, and the reasons why you need to make certain assumptions in order to apply that data to normal distribution. So yeah, I hope you found this video useful despite me being a bit ignorant about statistics. I'm, I don't know why, but yeah, I think I need my GC to actually show it properly. So let me see if my GC worked or not. If you found this video useful, please press the like button and subscribe. And with that, I would like to say thank you and bye.